What's up everyone? This video is about FRQ 4 of the 2022 Calc AB exam. Make sure to subscribe to know when I post new videos. Let's go take a look at what the problem says. An ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. The radius of the base of the cone is given by a twice differentiable function r, where r of t is measured in centimeters and t is measured in days. The table above gives selected values of r prime of t, the rate of change of the radius, over the time interval 0 less than or equal to t less than or equal to 12. This is a table problem and it gives us t and r prime of t in the table. Part A tells us to approximate r double prime of 8.5 using the average rate of change of r prime over the interval 7 less than or equal to t less than or equal to 10. Show the computations that lead to your answer and indicate units of measure. We're looking for r double prime at t equals 8.5, so we're looking for the average rate of change of 7 and 10. To get the AROC, we just do r prime of 10 minus r prime of 7 over 10 minus 7. Now we plug in the values and we see some decimals. Since this is a non-calculator question, leaving your answer like this is perfectly fine. You would get full points, save some time, and also avoid making a mistake. But if you did simplify it, the answer would be negative 0.2. The units are centimeters per day per day. Now let's go to part B. Is there a time t 0 less than or equal to t less than or equal to 3 for which r prime of t equals negative 6? Justify your answer. We look at the interval 0 to 3 and we find that r prime changes from negative 6.1 to negative 5. Because negative 6 is between these two numbers, IVT applies. We need to write out a proper statement that fully proves IVT. First, we need to show that r prime is continuous. The problem says that r is a twice differentiable function, meaning r prime is differentiable, and that r prime is also continuous. Then, I usually write something like, by IVT, since r prime of 0 is less than negative 6 is less than r prime of 3, then r prime of t equals negative 6 for at least 1t in 0, 3. Your statement probably varies, but make sure that you prove continuity and show that negative 6 is between the r prime values. Next, let's take a look at part C. Use a right Riemann sum with 4 subintervals indicated in the table to approximate the value of an integral from 0 to 12 of r prime of t dt. A right Riemann sum with 4 subintervals. So we need to use 3 minus 0 times r prime of 3 plus 7 minus 3 times r prime of 7 plus 10 minus 7 times r prime of 10 plus 12 minus 10 times r prime of 12. We can plug the values in, and for this problem we should definitely leave it like this. When I took the exam, I knew that simplifying it would take too much time, and also I was pressured by the time limit. The chance of me getting a calculation wrong would be really high. Part D says that the height of a cone decreases at a rate of 2 centimeters per day. At time t equals 3 days, the radius is 100 centimeters and the height is 50 centimeters. Find the rate of change of the volume of the cone with respect to time in cubic centimeters per day at time t equals 3 days. This is a simple related rates problem. First, all we have to do is write out everything the problem gives us. It tells us the formula for volume, also that dH over dt is negative 2, R is 100, and H equals 50. We want to find dV over dt. Let's differentiate V and make sure to use the product rule. dV over dt equals pi over 3 times, parentheses, 2r times dr over dt times h plus 1 times dH over dt times r squared. We can plug in the values r, dH over dt, h, r again, and from the table, we can also obtain dr over dt at time t equals 3. We can write it out like this and stop here afterwards. If you did simplify it, it ends up being negative 70,000 pi over 3. The units are given in the problem, centimeters cubed per day. Alright, that was FRQ 4. I felt that this question wasn't that bad and it just goes over the basics, such as AROC, IVT, and Riemann sums. The related rates wasn't too hard either, and you just have to write out everything you know and then piece together the problem afterwards. Did you have any trouble on any of the parts? Definitely review them if you did, since they are very common topics. Also, like and subscribe to keep up to date when I post something new. I'll see you in the next video.